So there are two ways to store hydrogen on an aircraft at the moment, in its gaseous form and its liquid form. Gaseous requires really heavy, highly pressurised tanks, so it's only really viable for those small aircraft, the kind that Cranfield Aerospace is currently focusing on. To properly decarbonise aviation, we're going to need to use liquid hydrogen. The reason for that is they don't require really heavy pressurised tanks. They require highly insulated tanks because it has to be stored at minus 253 degrees Celsius. It does allow you to keep on board a whole lot more fuel, which is what you need for these larger aircraft that need to go further with all these passengers. But gaseous hydrogen, even though it has got its limitations, it's the ideal entry-level form of the fuel. And the reason for that is it's a lot simpler. It's easier to handle, it's easier to store, it's easier to transport, and it's also already used across quite a number of industries. So we know a lot more about how to handle, store and transport it. And the infrastructure is simpler as well. And because of that simplicity, it's much more appropriate for those smaller, more remote airports that you'll see these small aircraft flying from, hopefully later this decade. So why is it important that we start with these small aircraft? Why don't we just wait until liquid hydrogen technology is ready and we can decarbonise aviation with larger aircraft? The reason for that is actually twofold. Firstly, by getting this technology, albeit gaseous not liquid, into the market earlier, we're driving the regulations required to understand how to use hydrogen as an aviation fuel in an airport, as well as in maintenance facilities and also in airline operations. And essentially, the earlier we start that process, the better. We've already seen gaseous hydrogen refuelling of a baggage tug at Bristol Airport, airside in an operational airport. And in Scotland, Cranfield Aerospace are working as part of the Sustainable Aviation Test Environment to look into what it means from a standards and regulation point of view to refuel gaseous hydrogen aircraft in a commercial airport environment. But the second reason why it's important is because it's more than just a technology step. Hydrogen in aircraft will be more cost effective once we get over that initial transition period. It's going to be more cost effective than kerosene, which means that those smaller operations that currently find it very difficult to make a profit on the economics of kerosene will suddenly become profitable again. And what we will see is a resurgence of the sub-regional market back to the days about 20 years ago when it was really quite vibrant. In the last 20 to 25 years, we have lost almost 50% of those short-range sub-regional routes. What hydrogen and gaseous hydrogen can bring in small aircraft is the resurgence of that market and create that sub-regional, regional connectivity that is kind to the environment and that is being cried out for. Perfect example of this, if you want to travel from Glasgow to Skye, it will take you 5 hours in a car, 6 hours by public transportation, less than 1 hour on a zero-emission sub-regional flight.